live. Another very, very important session, that is trailing zeros. Very interesting topic, and this trailing zeros topic is an extension of highest powers topic. Students who are very, very comfortable in highest powers should be able to understand these trailing zeros very, very clearly. In case if you are a student who is watching these trailing zeros session, to all the enrolled students, there are two sessions I did, session number 1 and session number 2, which talks about all the fundamentals of highest powers. Related to highest powers, if you know all the fundamentals, trailing zeros, it will be very clear. Trailing zeros, what is the meaning of trailing zeros? It means zeros at the end. Zeros at the end. Number of zeros at the end. Please write down, sir. Number of zeros at the end. It is called trailing zeros. Number of zeros at the end, it is called trailing zeros. Trailing zeros, we will solve a lot of very good problems from trailing zeros. Like you know, in every classroom, we are going to discuss this structure in every class. Every subtopic goes through this structure. Trailing zeros, first we will do definition based problems, basic foundation level problems, intermediate level problems, advanced level problems, and exam model questions. Exam model questions, totally around 65 plus high quality questions covering all the varieties. I kept it out in these PDF. High quality problems. Students who are preparing at a basic level, definition problems are there. Students who want a very classic level questions, I kept it in the advanced level. Definition, basic foundation level, intermediate level problems, advanced level problems, and exam model questions. Total 65 plus high quality problems are there. I think around 3 to 4 hours are required to complete all the problems. On an average, about 15 to 20 questions we solve it per hour. So I think in case if I develop new questions in the class, it should take anywhere from minimum 3 hours to language. Important key points. Important key points revisited so that we will start using in the foundation problems. What are the important key points? Every natural number can be written as power of prime basis. Every natural number can be written off as a power of prime basis. A natural number based on the number of factors. There are 3 kinds of numbers. One is a prime number, one is a composite number, and another one is neither prime nor composite. Every natural number can be written as a power of a prime basis. Second point, suppose if I take 4 factorial. 4 factorial, the definition of factorial is, it is the product of all natural numbers from 1 to 4. From 1 to 4, what are all the prime numbers? Prime numbers are 2 and 3. So 2 power something will be there, 3 power something will be there. Finding out the value of x and y. Finding out the value of x and y is all about doing the highest powers chapter. Finding out what is the highest power of a prime number. Finding out what is the highest power of a prime number. That is what we discussed in highest power session number 1 and 2. 4 factorial, it is 4 into 3 into 2 into 1, which is 2 cube into 3 into 1. 24 can be written as 2 cube into 3 power 1. Why we got 2 cube? Now if you see, there are 2 multiples of 2. 2 ones are 2 and 2 twos are 4. And 2 twos are 4. 4 I am dividing it by 2. 2 twos are 4. That means there are 2 multiples of 2. But in 4 there is an extra 2. Every power of 4 is also a power of 2. Every power of 16 is also a power of 2. Again divide, 2 ones are 2, 2 ones are 2. So what is 2 plus 1? 3. What is these 2? 2 says that there are 2 multiples of 2. It is 1 multiple of 4. Please write down in the same order, sir. It is 1 multiple of 4. There are 2 multiples of 2. There are two multiples of 2. There are two multiples of 2 and there is one multiple of 4. I hope it is clear. Please make a note in your notebook. Every factorial will have all the prime numbers from n to n if n factorial is given in the question. Another example, if it is 10 factorial, what are all the prime numbers from 1 to 10? Prime numbers from 1 to 10 will be 2, 3, 5 and 7. 2, 3, 5 and 7. So it is x1, these x2, these x3 and it is x4. What are all the prime numbers from 1 to 10? 2 power something, 3 power something, 5 power something and 7 power something. Finding out x1, x2, x3 and x4. Finding out x1, x2 and x3 and x4. It is all about the highest powers. Now see here. 10 I am dividing. Introduction. 2 5s are 10. What does this 5 denote? There are 5 multiples of 2. Again I am dividing. 2 2s are 4. There are 2 multiples of 4. 2 1s are 2. 2 1s are 2. So 5 plus 2 plus 1, it is 8. x1 value, it is 8. What is the highest power of 2 in 10 factorial? It is 8. 10 I am dividing it by 3. 3 3s are 9. What does the 3 denotes? There are 3 multiples of 3. Again divide. There is 1 multiple of 9. So 3 plus 1, it is 4. x2 equivalent to 4. Divide 10 by 5. 5 2s are 10. There are 2 multiples of 5. Definitely there are 2 multiples of 5. 5 1s are 5. 5 2s are 10. So 10, it is 7 1s are 7. So x3 value, it is 2. And x4 value, it is 1. x1. I hope the idea it is clear. First, whenever the factorial is given, a factorial, it will represent a natural number. Every natural number can be written as a power of prime basis. Every composite number, try to translate into power of prime basis. Third, suppose the question can be asked like this. Find the factors for 10 factorial. How many factors are there for 10 factorial? How many factors are there for 10 factorial? 10 factorial. What are all the prime numbers from 1 to 10? 2 power, how much we got? 8. 3 power we got 4. 5 we got 2. 7 we got 1. How many factors are there for this number? How many factors are there for this number? 0 to 8, 9. 0 to 4, 5. 0 to 2, 3. 0 to 1, 2. 15 2s are 30. 39s are 270. If a factorial it is given, first write the number as a power of prime basis. If a factorial is given, write the number as a power of prime basis. Then apply the factors concept. 0 to 8, 9. 0 to 4, 5. 0 to 2, 3. 0 to 1, 2. 9 5s are 45. 45 6 are 270. Some key points revisited. Almost all the questions, whatever we are going to solve based on factorials. So I'm just giving an introduction to factorials. I hope this key point, it is clear. Suppose if the question is, fourth key point, how to find out the factors, it is clear. Find the highest power for. Find the highest power for. First question, 2 in 100 factorial. 2 in 100 factorial. Second question, 5 in 100 factorial. 5 in 100 factorial. Third question, 10 in 100 factorial. Fourth question, 100 in 100 factorial. 100 in 100 factorial. Fifth question, 1300 factorial. 1300 factorial. Next one, 98 in 100 factorial. A recap of all the fundamentals we will do. Find the highest powers for 2 in 100 factorial, 5 in 100 factorial, 10 in 100 factorial, 100 in 100 factorial. Now listen carefully here. The last key point, fifth question, 100 factorial ends with 100 factorial ends with dash number of zeros. Once you understand the Foundation level question, trailing zeros, any number of questions you can solve it. Find the highest powers for 2 in 100 factorial. One by one we will solve. First question, see here, find the highest power for 2 in 100 factorial. 100 factorial is product of all natural numbers from 1 to 100. There is 2 power, 3 power, 5 power, 7 power, and so on up to 97 power. So 100 factorial can be written as a power of prime basis. These 2 power x into k. What is k? K is the power of prime basis. K is the power of prime basis. K is the power of prime basis. 3 power, 5 power, 7 power, 11 power, 13 power, 17 power, and so on up to 97 power. It is always good to write like this because there are certain problems which can be solved very neatly by writing rightly like this. 100 factorial. So 2 power we want. Answer will be 100. 2 5s are 2 50s are 100. Again, what is 50? There are 50 multiples of 2. There are 25 multiples of 4. Every power of 4 is also a power of 2. 2 12s are 24. 2 6s are, 2 3s are, 2 1s are. So add all this because every power of 4 is also a power of 2. 6 plus 3, 9, 10, 22, 90, 47, 97. So 100 factorial can be written as 2 power 97 into k. Highest power of 2 in 100 factorial. Answer will be 97. Answer for this question will be 97. First question, very, very easy question. Second one, 2 is a prime number, 5 is also a prime number. 5 in 100 factorial. 100 factorial can be written as 5 power x2 into k2. Here x1 into k1. So 5 is a prime number. First, how many multiples of 5 are there till 100? 20s are. 5 4s are 20. 20 plus 4 is 24. So it is 5 power 24 into k2. What is the highest power of 5 in 100 factorial? Answer for this question is 24. First and second, easy questions. Given number, it is a prime number. 5 is also a prime number. 10, 100, 30 and 98, they are not prime numbers. A and B are 2, 5 are prime numbers. Just to learn in the same structure, sir. Once we discuss advanced level questions, you will understand why we are going from basics. And the given numbers are composite numbers. Given numbers are composite numbers. Now third question. What is the third question? 10 in 100 factorial. 10 in 100 factorial. What is the concept we discussed? Every natural number can be written as a power of prime basis. 10 is a natural number, so it can be written as a power of prime basis. So if composite number is there, write down it as a power of prime basis. Why we are writing it as a power of prime basis? Prime is the first number. Composite number is the inherited number. Composite number is the children of prime numbers. 4 is derived from 2. 9 is derived from 3. 12 is derived from 2 and 3. 2 and 3 are at the top of the tree. Remaining all are derived. 2 into 5. So already we did it for 2 and 5. 2, what is the answer we got? 100 factorial it is. 2 we got 97. 5 we got 24. 5 power 24 into k. We want 10. 10 is single power of 2 and single power of 5. So I can take 24 into 2 power 73 into k. 2 into 4, 5, it is 10. 10 power 1 will have 1 0 at the end. 10 power 2, 100, there will be 2 zeros at the end. So, what is the highest power of 10 in 100 factorial? 24. Another very, very important point. Number of zeros at the end. number of zeros at the end. Number of zeros at the end. It is also called trailing zeros. Number of zeros at the end. It is also called as the trailing zeros. It is given by highest power of 10. Highest power of 10. Highest power of 10. If I want the number of zeros at the end, I need to take the highest power of 10. 10 is a composite number. A composite number will be written as a power of prime basis. So 2 and 5. Very, very important. Write down in the same structure. At the end of the class, everything will be in a neatly packed, structured order. Number of zeros at the end, it is highest power of 10. 10 power 24 we got. 10 power 24 we got. So number of zeros or number of zeros at the end. From now onwards, I will use the word trailing zeros. Number of trailing zeros for 100 factorial. Number of trailing zeros for 100 factorial will be 24. Number of trailing zeros for 100 factorial will be 24. Now one important key point. Listen carefully, sir. 100 factorial. It is written as 1 into 2 into 3 into 4 into 5 and so on up to 98 into 99 into 100. The definition of factorial is, it is product of all natural numbers from 1 to 100. Now if you see, every second term, it is a multiple of 2. Every second term, it is a multiple of 2. Now, if you observe, every fifth term, if I take 10, every fifth term, it is a multiple of 5. If I am writing 100 factorial as 1 into 2 into 3 till 100, there are 100 terms are there. 50 terms are multiples of 2, but 20 terms are multiples of 5. So obviously the powers of 5 will be less compared to the powers of 2. That means, please write down this point. In factorial problems, power of 5 is less than power of 2. Very, very important key point. In factorial problems, power of 5 is less than power of 2. Because power of 5 is less than power of 2, I will be taking the highest power of 5 if I am finding the trailing zeros for factorial problems. Only for factorial based problems. Number of zeros at the end, we will take highest power of 5. Why we are taking only highest power of 5? 100 factorial is 1 into 2 into 3 till 100. Every second term it is a power of 2, but every fifth term is a power of 5. So number of terms 5 will be present is 20 here, but here it is 50. So the number of terms for 2 are greater than the number of terms for 5. Obviously the power of 5 will be less. In factorial problems, power of 5 is less than power of 2. Power of 5, it is less than power of 2. I hope the idea it is clear. Next question. Next one. 100 in 100 factorial. 100 in 100 factorial. First of all, check whether the given number, it is a composite number or not. 100 is a composite number. It can be written as 2 square into 5 square. So 100 factorial, power of 2 is 97. Power of 5, we got it as 24 into k. I hope it is clear. What is k? K is the power of prime basis other than 2 and 5. I want 2 square into 5 square. So 2 square into 5 square. Power 12, 2 power 24. It is 2 power 73 into k. So 4 into 25. What is the highest power of 100 in 100 factorial? It is 12. 100 in 100 factorial, it is 12. Some students in hurry, 100 factorial, it is 100 into 99 into 98 into and so on up to 25 and so on up to 5 into 3 into 2, and so on up to 1. Now what probably in hurry, 100 is present only once, they might tick mark 1. But if you see here, 50 into 2 is 1, 25 into 4 is 100. Like that, there are lot of possibilities that will arise. So these, in between 90, there is 5 into 18. 80, there is 5 into 16. 70, it is 5 into 14. Here, 5 into 5, 25, 25 into 16 is a multiple of 200. There are so many powers of 100 that we are getting in 100 factorial. 100 factorial, it is a composite number. Write down it as a power of prime basis. 2 square into 5 square. So 2 square into 5 square, power 12. So 2 12s are 24. 2 12s are 24. Now if you see here, if I take the highest power of 5, it is 24. To get 100, I require 5 square, so 24 divided by 2, it is 12. I hope it is clear. Very, very good question, sir. What are the other questions that we missed it out? 1300 factorial, 98 in 100 factorial. 1300 factorial. First we will understand 1300 factorial. 1300 factorial, what is the next question? F. F will be, the question will be 98 in 100 factorial. 98 in 100 factorial. Listen carefully, sir. 98 in 100 factorial. So 98 is a composite number. It can be written as a power of prime basis. 2 into 7 square. 2 into 7 square. 7 square, it is 49. 49 2s are 98. So 100 factorial, it will be 2 power 97. Already we did. For what are the multiples of 7 that I will get? 14 multiples of 7. How many multiples of 49 will be there? 2. 14 plus 2, 16. So 7 power 16 into k. So this will be 2 into 7 square. Power 8 into 2 power 87 into k. So what is the highest power of 98 in 100 factorial? Answer will be 8. Very, very easy question. Then I will get into, like I told you, it goes through the 5 layers. First definition based question, foundation based question, intermediate level questions, advanced level questions, finally exam model. So that everything will be there properly in your notebook. 1300 factorial. 30 is a combination of 3 prime bases. 2 into 3 into 5. 100 factorial. Highest power of 2 in 100 factorial. 97. 5 I got it as 24. 5. So 3 it is 33s are, 3 11s are, 3 3s are, 3 1s are. 44 plus 3, 47, 48. So it is 3 power 48 into k. So this can be written as 2 into 3 into 5. What is the lowest I can take? 24. 2 power 24 is a sub-element of 2 power 97. 3 power 24 is a sub-element of 3 power 48. So remaining k2 I will get. So what is this answer? Answer will be 2 into 3 into 5. 30 power 24, it will be 24. This is the foundation based problems for the highest powers. To get the number of zeros at the end, we require the highest power of 10. To get the highest power of 10, we need the highest power of 2 and 5. That is the reason introductory questions I discussed. Introductory question, how to find the highest powers. Now let us write down some important questions.